Hey there everybody, so it's time for our practice test. It is test review day because we have our test tomorrow. That means this is going to be kind of a long video because I'm going to go through every single problem on this with you. Now you know where that fast forward button is. If you don't need to see every problem, maybe you've already checked your work against the answer key and you only missed this one and that one, feel free to fast forward and rewind just however it helps you most. It's your time, so I'm going to let you use it the way you want to use it, okay? So let's get started with problem number 1. In a group of 154 students, 4 out of 7 like math more than English. How many students in this group like English? Okay, so 4 out of 7 math to English. Okay, so let's do math on top. Then you have English, and then you do have a number for the whole. So let's write, sorry about that, let's write our whole down here. Okay, so let's see, 4 out of 7 like math more than English. So 4 like math. It says 4 out of 7. So what is that 7? Is that the number that like English or is that the whole? When it says 4 out of 7, when it uses the words out of, that means that 7 is the whole. So let's put the 7 right there. Now that we have this, let's go ahead and figure out how many like English. 4 plus what equals 7? 4 plus 3 equals 7, so we're going to write that 3 right there, because this number plus that number always needs to equal the whole. Okay, so now what else can we write? It says in a group of 154 students. So that's a total number right there, 154 total students. So we're going to put that over here in the whole row. And now we just need to figure out this blank. This blank is going to be the number of students in this big group that like English best. So let's figure out our scale factor. What can we multiply 7 by to get 154? Well, I don't know about you, but I don't know that off the top of my head. So what I can do is 154 divided by 7, and that's going to get me the scale factor. So let's do that. 154 divided by 7, 22. So it looks like we're multiplying by 22 here. So you can do it again just to make sure. 7 times 22, yeah, 154, great. So that means we need to multiply the 3 by 22 to figure out that blank. And if we wanted to figure out that blank, we'd multiply the 4 by 22 also. In this case, we don't have to do it though. So 3 times 22 is going to equal 66. All right, and if you want kind of a nifty way to double check yourself, you could, like I said, multiply that by 22 and you'd get 88. And then you're just going to make sure that 88 plus 66 equals 154. It does. All the pieces are fitting together. But the piece of information you really need is the 66. So 66 like English. All right, going on to problem number 2. Danny has $248 in a savings account. The ratio of his savings to Jill's savings is 8 to 6. Okay, so we have Danny's savings to Jill's savings. I'm going to put D and I'm going to put J. How much does Jill have in savings? All right, so we have the total amount Danny has, and we're asking about the amount Jill has. There's no mention of any kind of whole or total or the amount they have altogether, so I'm not going to write a whole. We do not need that in this case. Would it hurt you to have it? No, it wouldn't hurt you, but we don't need it, so I'm going to skip it. Okay, so their ratio is 8 to 6, Danny to Jill. 8 to 6. Okay, now over here, that's going to become 248 for Danny. So 248 goes here, and I can just set up my proportion now. So 8 times what equals 248? Again, to find out that scale factor, do 248 divided by 8. Now if you're thinking, wait, can't I just cross multiply? Yes, you absolutely can. You can do either way. Pardon me. Okay, so it looks like that scale factor is going to be 31. So now I'm going to do 6 times 31, and that's going to get me 186. Now, if you had wanted to cross multiply, I would put an X right here, and you draw your little butterflies, and you'd get 8X equals 6 times 248. You're going to simplify that. 6 times 248 equals 1,488, and then you're just going to divide everything by 8, and that's going to get you the same number, of course, 186. So either way, the answer is Jill has $186 in savings. Okay, that was number 2. Let's do number 3. It says solve each proportion, round to the nearest hundredth if necessary. So hundredths, that's 2 decimal places. So here you have x over 5 equals 8 over 10. You can either use cross multiplication or you can use scale factor. We're going to do some of each. In this case, I can spot that the scale factor is times 2. So for me, it's easiest to think what times 2 equals 8. And I know that's going to be a 4. So 5 times 2 equals 10. 4 times 2 equals 8, so x equals 4. I'll definitely show you cross multiplying on some of these others too though. Like for example, this one. What can I multiply 14 by to get to 21? It'd be some kind of decimal. Let's not worry about that. Let's just do cross multiplying. So you're going to do 14y. So multiply these 2 numbers together and set it equal to these 2 numbers multiplied together. Let's go ahead and simplify. 18 times 21. 18 times 21 is going to give us 378. So 14y equals 378. Now we're going to divide everything by 14 to get rid of that and get the y by itself. Y is going to be equal to 27. And that is your answer there. Okay, now here we have a binomial, and if you remember, the first step when you have one of these binomials in your proportion is to put those parentheses around it. So let's do that. And now we're going to cross multiply. So you can draw your little butterfly wings. And you've got x times 12. Well, we're going to write that as 12x. That's just how we do it. 12x. And then we have x minus 12 times 15. Again, I think it's better if the 15 goes in front. So I'm going to write 15 parentheses x minus 12. Just like that. And that shows the multiplication right there because the 15 is next to the parentheses. Now, what are we going to do with this to solve it? We are going to distribute. So let's go ahead and draw our little arrows, and we'll simplify. So 12x equals 15x minus, let's see, 15 times 12. 15 times 12. 180. And that minus there is there because a positive number times a negative number is a negative. If it had been a negative 15 times a minus 12, then it would have been positive. So just watch out for those. Okay, let's keep solving. We're going to add 180 to both sides. Nope, we're not going to do that. Sorry, I should look at the problem first. So let's, now we have variables on both sides. So this is one of those questions that I'm actually going to let you guys skip. I just didn't look over this carefully enough. My apologies. We are going to skip this one. Skip. Let's keep going. Number 6. So how can you turn a 15 into a 46? It's not so easy. So let's just cross multiply. 15x equals 5 times 46. So you're multiplying those together and you're multiplying those together and setting them equal. 5 times 46 equals 230. And you bring down your 15x. Now you're just going to divide everything by 15 to get that x by itself. And you're going to get x equals 15.3. Or you could have written it as 230 over 15 and then simplified your fraction. That would be totally fine. I believe you get 46 over 3. Let me double check. Yes. So this answer or this answer, both of those are totally good. All right, let's go to number 7. Here we have another binomial, but this one I definitely do want you to do. Anytime you have a binomial, I definitely encourage you to use the butterfly or cross multiplication method. So draw those circles, and you're going to be left here with 26 times 3 equals 8 times k plus 2. Okay, so what do we do here? We distribute, and let's do that. 26 times 3, let's go ahead and simplify that. 26 times 3 is 78. And that's going to equal 8 times k, in other words, 8k. And then 8 times positive 2 is positive 16, so we're going to write plus 16. Okay, now let's get rid of this 16 by subtracting it from both sides, and we're going to be left with 62 equals 8. Is that right? Yes. And then divide everything by 8 really quick, and so you're left with 62 over 8, which simplifies to 31 over 4. Or you can just divide, totally fine if you want, and that would be 62 divided by 8 equals 7.75. So any of these answers is fine. All right, let's see what else we have here. This is one that you're going to skip as well. Okay, moving right along. It says circle proportional or not proportional for each of the following. And then don't forget this part. Explain why your answer is correct. Okay, so here, is this graph proportional or not proportional? Well, for a graph to be proportional, it has to meet two requirements. It has to, number one, be a line, not some kind of curvy thing. It has to be a straight line, and it has to go through 0, 0. What do I mean when I say 0, 0? I'm talking about this point right here where the graph all meets up together. That is 0, 0. So is this a line? Yeah. Does it go through 0, 0? Yes. So it is proportional. Boom, boom. What about this one? Is it a line? Yes. Does it go through 0, 0? No. So not proportional. So it's not proportional because it doesn't go through 0, 0. That is really messy. Sorry, guys. Doesn't go through 0, 0 is what I wrote there. All right, let's look at the tables down here. So how do you figure out if a table is proportional? Well, you need to figure out all of your unit rates. All of these ratios need to be the same, and it's easiest to compare your ratio if you have the unit rate. So what you're going to do is you're going to divide your y by your x. Your y by your x. Each time, divide the y by the x, and you should get the same thing all the way down. So let's start with -3 divided by -1. -3 divided by -1. Well, two negatives, rather a negative number divided by a negative number equals a positive. And so 3 divided by 1, that just equals 3. Now guys, when you have 0 divided by 0, you skip that one. Just write NA. Why? Because you can't divide anything by 0. It's impossible. So you get to actually just skip that one and not worry about it. All right, what about 6 divided by 3? That is going to equal 2. Oh dear. Well, that one equals 3, and that one equals 2. So I'm going to say not proportional. I don't even have to do the rest, because as soon as you have two different numbers, you know it's not proportional. So I'm just going to say, this is the y part, the explanation part. Different unit rates. Okay. What about on number 12? Again, we're going to find our y over x. So 10 divided by -2 is going to be -5. And if you want to use a calculator on these, totally fine. Just make sure you're entering it carefully with the negatives and everything. 5 divided by -1 equals -5. Ooh, 2 for 2. Let's keep going. -15 divided by 3 equals -5. Hey! -20 divided by 4 equals -5, and -50 divided by 10 equals -5. Guess what? Proportional unit rates match is the reason. All right. Okay, so numbers 13 and 14, guess what? You don't have to do those either. Skip those. And now let's look at the next page. All right, so we have this competitive eating champion again, Joey the Jaws Chestnut. Apparently he's a real guy. I wouldn't know. Maybe you guys have heard of him. Joey the Jaws Chestnut, the famed king of eating contests, can eat 66 hot dogs in 11 minutes. I mean, really, 66 hot dogs? All in your stomach at the same time, that is really something. Let's go ahead to part A. Complete the table below to show the relationship between minutes and hot dogs. Okay, so let's think about this for a second because we don't have any labels anywhere. What should we figure out? Hot dogs per minute or minutes per hot dog? Really, what we're going to do is hot dogs per minute. Hot dogs. My phone is going crazy. Sorry about that, you guys. Hot dogs per minute. Okay, so that means, you know how we always do y on top and x on bottom, right? So if you have hot dogs per minute, then x is going to be the minutes and y is going to be the hot dogs. So x minutes, we're going to put minutes here. And you can write an x there too. It's kind of nice to be thorough, right? And then over here, y and hot dogs. All right. So it says complete the table below to show the relationship between minutes and hot dogs. Okay, so we don't really know our unit rate yet, but can we find it? Totally. So we have hot dogs over minute. Let's just use this space up here. We're going to do 66 hot dogs divided by 11 minutes. And 66 divided by 11 is 6. So you know that he can eat 6 hot dogs per minute. That is his unit rate. So 6 hot dogs per minute. Now, what are we going to use for our data? Let's do 0, 1, 2, 3, and 4. Now, you might want to fill this out differently, but it's handy this way. You can do it however you want, though. So how many hot dogs has he eaten after 0 minutes? 0, right? Because he hasn't even started yet. But after 1 minute, how many has he eaten? Well, he can eat 6 hot dogs per minute. So after 1 minute, he has eaten 6. I need to turn my phone off. I'm so sorry. Oh my goodness, I'm making a mess. Okay. Now, okay. So after 1 minute, he's eaten 6. After 2 minutes, he's going to have eaten another 6. So let's just keep adding 6. And then after 3 minutes, he will eat another 6. So that makes 18. And add another 6 for after 4 minutes, and you're going to get 24. Now, if you had 11 here, of course, you'd have 66 over here because that's our original information up there, but I don't feel like we really need that in our table, and that's totally fine. So, excuse me, it says graph the data from the table and show the relationship between minutes and hot dogs. Okay, so nothing is labeled here. That is on us. We have to figure out what goes where. So what is our x-axis going to represent? Let's see. X is minutes. Okay, that's not bad. Let's do minutes here. And that means hot dogs is going to be up here. Okay, so as far as minutes go, we can just go by the minute. We've got plenty of space here. 0, 1, 2, 3, 4, 5, and so on. As far as hot dogs go, we want to get up at least to 24. I doubt there are 24 marks here. How about we just count by 2s? That'll keep it easy. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. I'm just going to stop right there. And I'm going to start making some points. So 0, 0 is right here. 1, 6. So I do 1 on my x-axis and 6 on my y is going to go there. 2, 12. 2 on my x-axis, 12 on my y. 3, 18. 3 on my x-axis, 18 on my y. And now 4, 24. 4 up to 24. And then that's really all the data we have except for 11, 66. And there's no way I'm getting to 66 here, so I'm not going to worry about it. And that's fine. It doesn't have to fit on there. And does that make a line? It sure does. So our next question says, pick any point from the graph or table, write it below, and explain what it means in the context of this situation. Pick any point from the graph or table. So I'm going to just randomly pick this point, but you could choose any of them. What this one means is in 2 minutes, because I followed that down and it goes to the 2 for the minutes. So what can he do in 2 minutes? Well, let's follow it this way to find out. In 2 minutes, he can eat 12 hot dogs. In 2 minutes, he can eat 12 hot dogs. Okay, so we should talk about this for a second because it kind of shows the limitation of this mathematical reasoning. The math holds true for the first few minutes, right? In 4 minutes, he can probably eat 24 hot dogs. And apparently in 11 minutes, he can eat 66 hot dogs. But what about in 100 minutes? In 100 minutes, could he eat 600 hot dogs? I mean, really, 600 in one person's stomach? Or what about in 1,000 minutes? Could he eat 6,000 hot dogs? So this math has a limitation for sure. This line, the way I drew it, goes theoretically forever and ever, but in real life situations, they would probably end at some point because poor Joey's stomach, I mean, my gosh. All right, part D. Write an equation to represent this situation. Okay, so we have x here, and I'm just going to write an x right here in my table just so I can kind of keep it straight. So this is x, I'm going to write my x right here. Now I want to write this number in terms of x. So what am I multiplying by each time to get this next number? It's actually the same thing as the unit rate, right? I'm multiplying by 6 each time. And look, 6 was our unit rate. So over here, what I'm going to write is 6x. X times 6 is 6x. So when I go to write my equation, what I'm going to write is y is equal to 6x. Okay, just like that. And then it says be sure to state what the variables represent. So you can just copy that from down here, from up there. X equals minutes and y equals hot dogs. All right, x equals minutes, y equals hot dogs. What's the unit rate? Include labels. Now we were just talking about how the unit rate is 6, just like up here, because we divided it out, and that is hot dogs per minute. So we talked about how to get that just a second ago. If you need to rewind and hear that again, just go back to where I was writing up here, okay? Let's go to part F. Circle where the unit rate appears in the equation on the graph and the table. Let me get my highlighter. You're welcome to highlight or do however works for you. Okay. Unit rate on the table is going to be where x is equal to 1. That's right here. Okay? What about on the graph? It's still where x is equal to 1. So follow that 1 up. Oh, there's my dot, so it's right there. And in my equation, the unit rate is the number in front of the x. There you go. So it said equation graph table. It looks like we got all of those. Now it asks us, is the situation proportional? Well, for me, the easiest way to tell is to look at the graph. Is it a line? Yes. Does it go through 0? Yes. So we are proportional. Use the table, graph, or equation to give at least 2 reasons why it is or is not proportional. Okay, so graph. Line, check, goes through 0. 0, 0. Check. There's one reason. What about the table? Do all of these work out where 6 over 1 equals 6? 12 over 2, simplify it, it equals 6. 18 divided by 3, simplify it, it equals 6. So the unit rate all the way down is the same here. So that's what I'm going to say for the table. Unit rate stays the same. Okay. If Joey were given 30 minutes, how many hot dogs could he eat? Again, I'm not convinced he can actually eat this many, but let's figure out what it would be. I think the easiest way to do it, for me, is to use this equation that we wrote. This is not the only way, though, so I'll show you both ways. So y equals 6x. Now, what represents minutes? The x represents minutes. So I'm going to take that x out, and I'm going to replace it with a 30 because it says 30 minutes here, right? So y equals, well, I wrote this down wrong. I'm so sorry. This should be a 6. All right, so now y equals 6, and instead of writing the x, I'm going to write a 30. So y equals 6 times 30, and that means y equals 180. So that means he could eat 180 hot dogs. Or you could set yourself up a proportion. Now let's see here. We're doing hot dogs per minute, so hot dogs on top, minutes on bottom. Now choose any piece of data here. I'm going to do the 6 and the 1. So 6 hot dogs on top, 1 minute on bottom, and that's going to equal something. I'll write an X, and then the 30 minutes goes down here. So you can figure out your scale factor if you want. It looks like we're doing times 30 times 30, so 6 times 30 is going to be 180. Or you could cross multiply, and that should give you the same exact answer. You can't read that. I'm going to write it again. There we go. So no matter how you figure that out, it's going to be 180 hot dogs per minute. No, per 30 minutes. He can eat 180 hot dogs in 30 minutes. Theoretically. I don't know if that's really true. You do not have to do numbers 16 and 17. Final thing I wanted to do with you is question number 10 from your 7.4, your part to whole. Now, why am I bringing this one back? Because you might be seeing some more things like this on your test. So let's just read this, go over it just as a quick review. I know you've done this problem before, but bear with me. On Friday, Harmon's had 35 boxes of Fruit Loops on the shelf. On the shelf. If 1 out of 5 contained a prize, how many did not contain a prize? Okay, so the whole. And then we have some who contain prize, and I'll do an N for no prize, okay? So 1 out of a total of 5 contain a prize. How many did not contain a prize here in the ratio? Looks like 4, right? And then in terms of the actual numbers, it looks like Harmon's had a total of 35 boxes on the shelf. 35 there. And now we need to know how many did not contain a prize. So we need to know what number goes right there. So guys, let's talk about that scale factor. 5 times what equals 35? 5 times 7. Yep. So 4 times that same scale factor of 7 is going to give us 28, and that is your answer. 28 boxes did not contain a prize. Okay, we're done for today. I'm going to sign off, and I will talk to you later. Good luck on your test. Let me know if you have any questions. Bye.